Hello and good day. Welcome back to our class. This is teacher Onen de Guzman and our topic for today is illustrating quadratic equations by tables. So let's talk about first the graphs of quadratic equations. A quadratic equation is one variable is a mathematical sentence of degree 2 that can be written in the form of ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a should not be equal to 0. So we have this first type of the graph of quadratic equation. So if a is positive, it means if a is greater than 0, then the parabola opens upward. And this is the illustration. Take note that this point is what you call the minimum point. It means the lowest value. On the other hand, if a is less than 0 or negative, then the parabola opens downward. So this is the illustration. Take note that this point is the maximum value of your quadratic equation. There are two ways to determine whether a function is linear or not. So the first one is by constructing a table of values and studying the differences in the variables. The second one is by studying the form of the equation that describes the function. So let's have here. So number one, in a linear function, equal differences in x produce equal differences in y, provided that we are in tabular form. Number two, if the first differences of y values are not equal, then take the second differences of y values in the tabular form again. If the second differences are all equal, then the function is quadratic. Otherwise, it is not quadratic. Let's have example number one. This table represents a quadratic function. Let's observe the table and get the difference on the values. So we have here 2 and 3, the difference is 1, or we can say that 2 plus 1 is equal to 3. Similarly, 3 plus 1, so 3 plus 1 will result to 4. Also, if we will add 1 to 4, will give us 5. Also, we have 5 plus 1 will give us 6. On the values of y, we have, if we will observe, 4 plus 2 will give us 6. Similarly, if we have 6 plus 2 will give us 8. Let's continue. So 8 plus 2 will give us 10. And 10 plus 2 will give us 12. So we have the same differences for x and then the same differences on y. So we can say that this is a linear function. Let's have example number 2. Does the table represents a quadratic function? So let's take the differences between x and y values. So we have here, so if we will add 2 to 0, so we have 2. Again, 2 plus 2 will give us 4. Next, 4 plus 2 will produce 6. And then 6 plus 2 will give us 8. So we have the same differences for the values of x. On the other hand, for the values of y, so you have 2 plus 4 will give us 6. Next, 6 plus 12 will give us 18. Next one, 18 plus 20 will give us 38. Also, the difference between 38 and 66 is equal to 28. Observe that on the first layer, we don't have the same differences. So we will move on to the next differences or the second differences. So we have here, if you will add 4 by 8, we have actually 12. Also, 12 plus 8, we have 20. Also, 20 plus 8, we have 28. Now, we have the same differences on the second layer. So therefore, we can say that this is quadratic function or quadratic equation. So, let's write here quadratic function. Let's move on to problem number 3. Does the table represent a quadratic function? So let's get the differences for the values of x as well as for the values of y. So we have 0 to 4, so we will add 4. From 4 to 8, we will add another 4. So 8 plus 4 will produce 12. 12 plus 4 will give us 16. So we have the same differences. On the other hand, we have 1 plus 9 will give us 10. 10 plus 7 will give us 17. 17 plus 5 will give us 22. Also, 22 plus 3 will give us 25. So we don't have the same differences on the first layer. So we will move on to the second differences. Okay? So observe that. So from 9 to 7, you subtract actually 2. So 9 minus 2 will give us 7. Also, 7 minus 2 will give us 5. Then 5 minus 2 will give us 3. Since we have the same now differences on the second differences, so therefore we can say this is quadratic function. So let's move on to problem number 4. How many square tiles are there in 6 steps? So we have here the number of steps. We have 1, 2, 3, 4, 5, and 6. And the number of squares is equal to 1, 3, and 6. So what we're going to do is determine the difference between 1 and 3. And the difference is actually 2. So we add 1 plus 2 is equal to 3. Next, here, 3 and 6 has a difference of 3. So if we will continue the pattern, so we have plus 2 plus 3, so this is plus 4. So 4 plus 6 will give us the value of 10. So let's write here 10. Okay? Next, we have the difference here between 10 and the next number is 5. So we have 10 plus 5 will give us 15. Next, so the difference between and the next number is 6. So we have 15 plus 6. So the answer is equal to 21. So we will write here 21 here. So the answer for the 6 steps, there are 21 1 square tiles in 6 steps. So that ends our discussion on illustration of quadratic equations. So do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you. So let's move on to the derivation of quadratic function from the table of values. Now, If we have this table, so to begin with, we will use the quadratic equation of y is equal to ax squared plus bx plus c. So wherein we will substitute first the value of x, which is equal to 0. Then we have here a times 0 squared plus b times 0 plus c. So y is equal to c. If y is equal to, or rather if x is equal to 1, we have y is equal to a times 1 squared plus b times 1 plus c. So we come up with y is equal to a plus b plus c. Next, if we will substitute x is equal to 2, so we have y is equal to a times 2 squared plus b times 2 plus c. Take note that we have 2 squared, it means 2 times 2 is equal to 4. So therefore, we have y is equal to 4a plus 2b plus c. And finally, we have here x is equal to 3. So we come up with a times 3 squared plus b times 3 plus c. So we come up with y is equal to 3 squared is equal to 9. So we have 9a plus 3b plus c. Now to summarize the tables that we got a while ago, so this is the original table. And then we will move on now to the right table. Okay, if we will substitute the value of x is equal to 0 until 3 to your quadratic equation. So again, like what we have done in the previous example, what we're going to do is to get the difference between these numbers. So we have the difference between 1 and 3 is 2. The difference between 3 and 7 is equal to 4, while the difference between 7 and 13 is equal to 6. So, since we do not have the same differences on the first differences, so we will move on to the second differences. So, the difference between 4 and 2 is equal to 2, and the difference between 6 and 4 is equal to 2. So, therefore, we can say this is a quadratic function. Now, we will do the same on this derived table. So we have a plus b plus c minus c, so we'll come up with the difference of a plus b. Next, so let's subtract 4a minus a will give us 3a. 3a. Then we have 2b minus b will give us positive b, and c minus c will give us 0. Next, we have here 9a plus 3b plus c minus 4a plus 2b plus c. So we come up with 5a plus b. Then, again, since we don't have the same differences on the first differences, we will move on to the second differences. That is 3a plus b minus the sum of a plus b. So we have 2a. Then, get the difference of 5a plus b minus 3a plus b, so we come up with 2a. So truly, we come up with the same differences on the second differences, so therefore we can say this is quadratic function. So let's move on. So to derive the quadratic function, so notice that we have the following numbers here. So we have 1, 2, and 2, as well as here c, a plus b plus 2a. So we are going to use that one in order to derive the quadratic function. So again, observe these numbers and this. So we can use the analogy this in order to get the values of a, b, and c. So we can say that 2a is the same as 2. So divide both sides of the equation by 2. So we can say that a is equal to 1. On the other hand, I have here a plus b. A plus b is equal to 2. Since I found out that a is equal to 1, substitute. So, in order to get the value of b, b is equal to 2 minus 1. So, b is equal to 1. Next, So I have the value here C is equal to 1. So I can say that C is equal to 1. Alright? So since I know the value of number of A, B, and C respectively, I will go back to the equation y is equal to ax squared plus bx plus c. Since I know the value now of A, B, and C, I'll substitute that now. So we have y is equal to 1, okay, times ax squared plus the value of b is equal to 1. So 1 times x plus the value of c is equal to 1. So to simplify this, so we have actually y is equal to x squared plus x plus 1. So this is the derived quadratic function of the given table. So again, this is Teacher Onen de Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.